Okay, we're looking at properties of logs. I'm assuming that you've seen this before, but I'm going to teach it like you've never seen it, only faster. Okay, so this first one, it tells us log base b of 1 would be equal to. Well, if we're not sure, you can always create a new variable. Our favorite letter is k. And then do what this I heart logs. So if you remember how we go from a logarithmic to an exponential function, we go b to the k is equal to 1. That makes a little, do you see that cheesy little heart? So if b to the k is equal to 1, what number do I need to, if I have some base, I can always raise it to the 0 power and get 1. Okay, so this first one, k would equal 0. This first one right here, log base b of 1 would always be equal to 0. The next one, I have log base b of b. Well, b to the 1 equals b to the 1. That's just going to be 1. So you can try going now from logarithmic form to exponential form. B to the 1 is equal to b. So that's just 1. So anytime the base here is the same as this base right there, you're just going to end up at 1. The next one, log base b of b to the x. Well, there's a few properties that you could use to get to this idea. One of them is this one right here, which we haven't talked about yet. The other one is, okay, let's set this equal to k. B to the k is equal to b to the x. This to the this equals that. If this is true, then k must equal x. So our property is that log base b of b to the x is just equal to x. So basically, when you have this base and this base, when they're the same, you're just left with that as your answer. It also works the same way with this, but this one's a little harder to see. So if I have b to the log base b of x is equal to y. We're trying to solve for y. On this one, this is currently in exponential form, where this is the base, here's the exponent, and that's what it's equal to. So if I want to put this into logarithmic form, log, here's the base of, it's going to be equal to this exponent, log base b of x. So it's b to the this equals that. Okay, let's make sure. I have a hard time sometimes, for whatever reason, going from exponential form to logarithmic form, but b to the this equals y. B to the that equals y, and we've done it correctly. Okay, so notice if I have log base b of y is equal to log base b of x, that tells us that y just has to equal x. Okay, so in other words, what you want to write in that box is that b raised to the log base b of x will just be equal to x. Those bases are the same. You can get rid of them and just hang on to that value there of x. Okay, the next one, the next property, log base b of x to the m. What we can do with this one is we can bring the exponent out in front. And this becomes m log base b of x. Now remember how we talked about this one could use that same thing? If I have log base b of b to the x, this would be equal to, I can bring this exponent out in front, x times log base b of b. Well, we just said log base b of b, this right here, is equal to 1, so this is just x times 1, or just x. So I can get the answer of this if I work, well, I can get there multiple ways, and one of them is using this particular property. The next one is this log base b of mn. What happens with this one is that we can split multiplication up with addition. Okay, so this can split apart. We can take the log of each one. Sometimes this is helpful. We can also work, we can go this way, we can also go that way. And so I've seen problems like log base 6 of 4 plus log base 6 of 9, and you were told to evaluate that without a calculator. Well, good luck. Until you realize that we can work backwards and use this property. And so this would be equal to log base 6 of 4 times 9. Well, 4 times 9 is 36. This is, notice, log base 6 of, this is 6 squared. Well, the bases are the same, and we're just left with 2. So I may not know what log base 6 of 4 is individually or what log base 6 of 9 is individually, but I know that together they're going to add up to 2. And notice how this property made that very easy. So sometimes there's a time and a place where we want to split them apart into 2, and there's also a time where we want to put them together, consolidate them to get a particular answer. The next, likewise, we also have a property that tells us that log base b of m over n. Well, there's 2 ways to think about that. That one is now here. You could think of this as being log base b of m times n to the negative 1. That's one way to consider this. And so we just said that our property was that when they're being multiplied, we can split them apart with addition. Well, then this splits apart with addition. But then what did we say about the exponent? Well, the exponent can come out in front. So this is log base b of m minus log base b of n. Well, and to be honest with you, I didn't realize this bit right through here until I'd been teaching for a few years. So the easy thing to remember is that when you're dividing here, they can split apart with subtraction. So when they're multiplying, they split apart with addition. When they're dividing, they split apart with subtraction. Be aware, this does not mean the same thing. So log base b of m over n is not the same thing as log base b of m divided by log base b of n. That is not the same thing at all. Don't make that mistake. And back up here, this is log base b of m plus log base b of n is not the same thing as saying log base b of m plus n. Okay, so these are wrong, bad, don't do this. On this one, there's not much we can do here. We have to add m and n first, and then we can take the log of it, but we'll see this, but there's not much we can do to simplify it. This one right here, we'll see this, there's a particular property for this, okay? So, and that, I think, is the last property up. There it is. This is what we call log base m of n. We can use what we call the change of base. The change of base property, which allows me to then say that this becomes log of any base of n divided by log of any base, that as long as it's the same, they have to be the same base of m. Okay, so this, notice, is a similar property to this. So we could write this out. Hang on, we could say log, base m over n is equal to log base b. Oh, no, how did I want to do it? Okay, now I remember what I wanted to do. Okay, my bad. So if I have log base b of m minus log base b of n, that's equal to log base b of m divided by n, which is not equal to log base b of m divided by log base b of n, but this is actually equal to log base n of m, because this is our change of base property. This is the change of base, and this is the division. So this is equivalent, and this is equivalent, but don't try and put them together. Okay? So there's a difference between dividing the numbers first, then taking the log, or taking the log, dividing your answers. That allows you to use the change of base property. And it used to be that we would be faced with something like this, log base 7 of 11. Well, now your calculator is sophisticated enough to handle that, but in the past it wasn't. In the past you could only do the log or the natural log. So we would say, okay, the natural log of 11 divided by the natural log of 7, or we would have said log of 11 divided by log of 7. Let me grab that calculator and show you what I'm talking about. These calculators now, if I go math, log AB, I can do log base 7 of 11. Or I can make it a fraction and say, I say that I can do that. Well, there's log. Log of 11 divided by log of 7. Okay, those numbers are the same. That is grand. Or we could do the natural log of 11 divided by the natural log of 7. Those all become the same. This has, the log right here had an understood base of 10. This has an understood base of e. And e, where's my little button for e? E to the first is equal to about 2.71 and so forth. There's definitely problems that I have seen in IB where you still need the, so, okay, the point was, in the past, you couldn't get the calculator to do this. Now the calculator can, that's great, that's wonderful. So if the calculator wouldn't do that, then you'd have to find one of these other two ways to type this up. But now I've also seen problems where you might have log base 4 of, I don't really care, plus log base 2 of something else. And you need to make them to have both have the same base. Okay, so I have definitely seen problems in IB where you have to use a change of base rule just to solve your problem. Even though the calculator might do this sort of thing for you, you still need to know this change of base. Okay, I hope that didn't make you too confused. Good luck. I would go practice. I'm going to make another video for some of these practice problems. So this video is long enough for now.